Okay, let's look at the horizontal asymptotes. All right, here's the definition. Y equals b is called a horizontal asymptote of f of x if limit at infinity is equal to b, or limit at negative infinity is equal to b. All right. There's a couple remarks, and because of the definition, either you can get one from here and one from here. There are at most two horizontal asymptotes for each function, so there are at most two. All right. But if you're looking at rational functions, there are at most one horizontal asymptote. Because you see that the limit at infinity, a positive infinity, or limit at negative infinity are always the same for rational function. So we can only get at most one horizontal asymptote. Right. So let's look at an example. Let's find a horizontal asymptote of e to the x. Right. So we're going to have to take the limit of e to the x as x approaches, say, positive infinity, and we should probably do that with negative infinity because this is not a rational function, so we have to check both negative infinity. All right, so you can see that this is going to be just e to the huge number, so maybe this might not be the best way to write it, but e to the infinity, e to the huge number is going to be huge, so it's going to go to infinity. Right? So which means that we don't get a horizontal asymptote from here. Right? How about this one? Right? This is e to the negative infinity, which is equivalent to, right, negative power is a reciprocal, so it's going to be equivalent to 1 over e to the infinity. Right? And e to the infinity is going to be big, so 1 divided by extremely big number is going to approach 0. All right, now we get a number, so therefore y equals 0 is going to be the horizontal asymptote. So from here we can find y equals 0, which is the x-axis, is the horizontal asymptote for e to the x. Right? So look at these two limits. All right. How about the next one? Next one is a rational function, so you can either do a positive infinity or negative infinity. The limit is going to be always the same. So I'll just do a positive infinity. Right? So we're going to take the limit of, as x approaches positive infinity, of g of x. Right? So let's use that trick. All right? Remember that we can just look at the leading coefficient, a leading term on top, which is this guy, and the leading term on the bottom, then take the limit. So it's going to be limit as x approaches positive infinity. My leading term on top is 2x squared, and leading term on the bottom is x squared. So you have x squared there. Right, then you have x squared on top and x squared on the bottom cancel out. So the limit is going to be 2. All right, so which means that we have a horizontal asymptote. So horizontal asymptote is going to be y equals 2. All right, so we can find the horizontal asymptote using the limit at infinity. All right, that's it. I hope that this was clear.